Okay, class, we're about to start section 9.3, surface area and volume. So far, we have been talking about flat objects or two-dimensional objects. Now we are ready to begin working with objects that take up space, which are three-dimensional. Two-dimensional objects, some of the characteristics are they are flat, can lie on a sheet of paper. Examples are the surface of a floor, a tabletop, a sheet of paper, and it has a perimeter and an area. Three-dimensional objects. They're not flat. They take up space. Examples are a box, a basketball, a pop can, and they have a surface area and a volume. Now we come down here to section A, surface area. Surface area is exactly what it sounds like it is. What do you think the surface area of the Rubik's Cube would be? Now that's something for you to ponder a little later. We're going to scroll down here to the next page. It says, important note, what kind of units does surface area have? Why? Now, surface area is still area. Area is always in square units. And also remember, too, the surface area is still a flat area. Even if we go back up here to this Rubik's Cube, and we look at the surface area of this Rubik's Cube, disregard these grooves here. This is still a flat surface. If you look at it, it's still a flat surface. So it will, with area, you always have square units. So you can find the surface area of any box by adding the area of each surface. Now, we come here to this example. It says, what would be the surface area of the box below? Okay, now we need a surface area formula. Now we could just do this. This looks like all rectangles all together here. And so we could just do the area of a rectangle and do that 1, 2, 3, let's say 1, 2, 3, 4, 5, 6 times. Or we could use this formula sheet that you have on page 315 of your course pack. Now with this formula sheet, if you go back to page 315 and you look under rectangular prism, it gives you the surface area. The surface area is 2 times the length times width plus 2 times the length times height plus 2 times the width times the height. Now, this is how we will go about doing that. Now, first thing I will recommend is that you label which one of these, what you want each of these values to be. For example, this 7 inches would be my length. This 4 inches would be my height. And this 2 inches would be my width. So we could do surface area of the rectangular prism or the box. So we will have 2 times the length times the width plus 2 times the length times the height plus 2 times the width times the height. Now we have surface area is equal to. Now one thing I need to do here, I need to change this H, make it capitalized, because whatever the variable is here, it must be the same thing here. We cannot have two different casings of the variables. So now we substitute. We have 2 times the length is 7 inches and the width is 2 inches. Plus 2 times the length is 7 inches and the height is 4 inches. Plus 2 times the width is 2 inches and the height is 4 inches. So we have surface area is equal to 2 times 7 is 14, times 2 is 28, and inches times inches is square inches. Plus 2 times 7 is 14, times 4 is 56, and inches times inches is square inches. Plus 2 times 2 is 4, times 4 is 16, and inches times inches is square inches. So now, we will have our surface area is equal to 28 plus 56, which is 84, plus 16 is 100. So it'll be 100 square inches, and that will be our surface area. Now, we will scroll. Now we come to cylinders. It says finding the formula for the surface area of a cylinder. And it says wrap candle. Now, what we're going to do is this here. With this example here, we would discuss this in class as far as how the formula is derived. So what we're going to do is we're going to concentrate on using the formula sheet I told you about on page 315 to help us solve these problems dealing with surface area and volume. So we need to scroll down. Okay. So now it says, so the formula for the surface area of a cylinder is, now remember, we can look at our formula sheet, and the surface area for a cylinder is 2 pi r squared plus 2 pi r h. Now that is the surface area of a cylinder. Now we scroll down here, it says example. What would be the surface area of the cylinder below? Now remember, our surface area is equal to 2 pi r squared plus 2 pi r h. Now we have 2, we'll substitute in the approximation 3.14 for pi. The radius, remember the radius is half this diameter, so it'll be 3.5 squared plus 2 times, we'll put in 3.4 approximation for pi. The radius would be 3.5, and the height would be 10 centimeters. Now, and remember this 3.5 is actually centimeters as well, even though I didn't write it. But you could write that down. You could put your centimeters in here and your centimeters in here. Okay, now we need to multiply this. Now you could take your calculator and multiply this out. 2 times 3.14. And then multiply it by 3.5 squared. Or you could just multiply 3.5 by itself twice. So this side here will give you 76.93 centimeters squared. Plus, now we'll take the other side. 2 times 3.14 times 3.5 times 10. And that will give 219.8 centimeters. Now when we add the two together, 76.93 plus the 219.80, it gives us 296.73 centimeters squared. And that's the final answer for that example. Now we come here to spheres. It says the formula for the surface area of a sphere is, now again, we can go back to that formula sheet. The surface area is equal to 4 pi r squared. Now, we're asked to find the surface area of this sphere. So we have surface area is equal to 4 pi r squared. So we have 4 times 3.14, and we're given a radius as being 5 feet. And that's squared. So it'd be 4 times 3.14, and 5 squared is 25, and feet squared would just be feet squared. Now when we multiply everything out, it'll give you 314 square feet. And that is the surface area of this sphere. Next we come to section B, volume. If surface area is the amount of wrapping paper you would need to cover a surface of a package, volume is the amount of stuff you would need to fill the package. Technically, it is the amount of space occupied by an object. Let's go back to our Rubik's Cube example. What would the volume of the box be? Now, that's something for you to ponder for later, like I said before. Let's look at this important note. What kind of units does volume have? It has cubic. cubic units. So that means everything will be cubed, because volume usually has, since it's three-dimensional, it'll be different numbers or the same numbers multiplied by itself 3 times with the 3 units. So like with like the volume of a box, which we'll talk about here, is actually length times width times height. That is the volume of a box, length times width times height. And you can write V equals. So the volume is equal to length times width times height. Now let's go through this next problem. It says, example, what would be the volume of the box below? So first thing we need to know is, what are these measurements? 7 inches is the length, 2 inches is the width, and 4 inches is the height. Now the volume of a box is length times width times height. The length, again, is 7 inches. The width is 2 inches. And finally, the height is 4 inches. 7 times 2 is 14, times 4 is 56. And inches times inches times inches is cubic inches. And that's the final answer for that problem. Now we come to the volume of a cylinder. The volume of a cylinder is pi radius squared h. So now we go down here and try this problem here. Okay, so now we have the volume is equal to pi is approximately 3.14. The radius is 3.5 because it's half of the diameter. And this is supposed to be centimeters. And then the height is 10 centimeters as well. So we have 3.14. Now we would take 3.5 times itself, or 3.5 squared, and that would give us 12.25. And then that should be centimeters squared times 10 centimeters. So now we would take 3.14 times 12.25 times 10. And that gives us 39. No, that's incorrect. I guess I didn't type in my calculator. 3.14 times 12.25 times 10. That would actually give us 384.65 centimeters cubed. That will be our final answer here. So remember, this is centimeters squared times centimeters. That gives us centimeters cubed. And we multiply everything out, it gives us 384.65. Okay, now we come to spheres. It says the formula for the volume of a sphere is, and we know volume is equal to 4/3 pi r cubed, which is derived on that formula sheet that I told you about. So now we want to know what would be the volume of the sphere below. Now we're asking this example, what would be the volume of the sphere below? So volume is 4/3 times pi times radius cubed. So we'll substitute. Pi would be approximately 3.14. The radius here is 5 feet. Now 5 cubed is 125 feet cubed. And then we'll put these values over 1. 4 times 3.14 times 125 gives 1,570 feet cubed. 3 times 1 is 3, times 1 is 3. When we divide these two, we're going to get an approximation. And I just want you to round to 1 decimal place. So it'll be approximately 523.3 cubic feet. And that is the final answer.